this is how we solve those problems with those complex circuit. So, okay. So first of all, this is complex circuit. So this is the one that I have given you this morning. The only thing I've done extra is I built the table already. Okay, once the table is built, then before we do anything else, now there is a process that I call the shrinking of the circuit. Okay, I will keep redrawing the same circuit over and over until I reach only the final circuit with only one loop. So every single one of those stuff that you guys talk about, usually they say, well, I have 3 circuits. Well, the circuit is one. It's just I have one loop, I have another loop, and I have another loop. Okay, so what I've done is I've taken whatever, once I calculate the current that is coming out from the battery, right? So this current will be through the resistance, and then so through R4 will split. Some will go into R2, some will go into the wire, and then from here some will go into R5, some will go into R7, will not branch, so we'll keep on going across, we'll keep on going across, we'll go through R6. So this current, the pink current, is the same. Once it gets here at this point, it will join with this current I5 because it's going through R5. So now I have this current that is going through this branch and is going to join with the orange one and will become blue again, and then the blue will join with this one and will become green again. Okay, all to start all over again. So those are the branches of the current. Okay, then I need another piece of paper and I'll start shrinking the circuit. I will start from the last loop. Okay, so I will copy everything but the last loop. Okay, so here I have the battery, I have the first circuit, the first resistor here, R1, I got R4 here, I got R2 here, I got R3, R5, and nothing on the bottom. So now the last loop are, because so I have to recognize what kind of loop is this. Because the current is not branching, then those 2 resistors are in series. So I can substitute those 2 resistors with a unique one, okay, that instead of being resistor 6 and resistor 7 is going to be the resistor 6, 7. Okay, and this is cool because this resistor is the series of the 2, so it has to be the sum of those 2. So R6 was 3, R7 was 2, so when I add 6 and 7 together I have a 5. So this resistor here is going to be 5 ohms. Then I'll do the whole process all over again. I'm starting from here, right? Branches, keep on going, branches, branches. So those 2 resistors are now in parallel. So I can redraw the circuit and I can say that this is again R1, this is again R4, this is R2, this is R3, but R5 and R6, 7 are in parallel. So here I can write this one as the solution of those 2. So this is the R5, 6, 7 resistor, which is equal to, because this is 5 and this is also 5, actually R5 is equal to 5. Okay, so then I can do this one as a 1 over 5 and 1 over 5, right? Because this is 5, this is 5, so 1 over 5 and 1 over 5, everything over 1 over 5. and I get, so 5 over and 5 over, enter, over. So this is 2.50 ohms. Okay. So now I have this resistor here. I can go again with the current, and I can say this one branches, so I have some here, but this current doesn't branch. So those two resistors are in series, and R3 is a resistance of 8. So this is 8, which means I can draw again the circuit, and I have R1, R4, R2, and the sum of those two, because those two resistors are in series. So this is 2.5, this is 8, so this resistor here is going to be 10.5. So this is the resistor 3, 5, 6, and 7, which is 10.5 ohms. Then I keep on going, so I go from here, branch off, so this and this are two resistors in parallel. So at this point I can draw again one more circuit, which goes like this. This is R1, this is R4, and this is R2, 3, 5, 6, and 7, and R2 is equal to 1, so this is 1 over 1, and 1 over 10.5. I put this one in the calculator, and I have 1 over 1 is 1, plus 10.5 over, enter, over, and this is 0.99. No, this is not, because I wrote it wrong. I put 105. So 1 plus 10.5 over, enter, over. Okay, 0.91. So this is 0.91 ohms. Then at this point I'm basically done. I only need the final circuit, which looks like the battery, and those three resistors are all in series. So I need only to add them up to find the R equivalent of the total circuit. Okay, so R1 is 2, so this is 2, R4 is 3, so the whole sum is 5.91 ohms. So I can write here 5.91 ohms as equivalent resistance. Finally, I can calculate the I equivalent by doing 15 divided by the 5.91, and I have a 2.54 amps coming out from the battery. So at this point I can say, well, this is the equivalent current, and I can go back in the whole circuit and say, well, this is the one coming out from the battery. So this one, which basically means this one, is going to be 2.54. Okay, so I'll take the green pen so that we can mark those currents. So 2.54 amps is here, and 2.54 amps is there. Okay, so now let's start filling in the table, and let's see what we need to adjust time by time. So this current is the one that is going through R1, so I can write 2.54 amps for I1, right? So this is equal to I1, and this one is going through R4, so this is equal to I4. So where I see I4, I go there and I put 254 also. Okay, and I'll stop right there, because already I can calculate some voltages. Again, the table is going to be your guide. Once you have two things, calculate the third right away. So here you have a 2 times 2.54, so you have a 5.08 volts across R1. So here, if I have the voltmeter placed there, I will read 5.08 volts. I can do the same thing for R3, R4. I have two things. I can calculate the third. So 3 times 2.54 gives me a 7.62. 7.62 the voltage across R4. So 7.62 volts is how much I'm reading here. Now, just like we were doing with the current, that when we go and branch off, we are losing some. In this case, I can do the same conversation there, and I can say that I'm losing this many volts on this side. I'm losing this many volts on the other side. So how many volts would I have across R2? So if I'm losing means minus. So I have a 15 minus 7.62 and minus 5.08. I have a 2.30 across R2. So here, if I have a voltmeter, I can read 2.30 volts. Okay, so this is V2, so 2.30 volts is going to be the voltage across R2. Now, look at your table. You got two things. You can calculate the third one. So V divided by R is equal to I. So this means that this current, right, the purple one, is going to be the one that is going across R2, which is going to be the 2.30 amps. So this is 2.30 amps. Now current-wise, I had 2.54. I'm losing 2.30. How much current do I have? So this current is going to be 0.24 amps, right? So this current is the same that is here because it's always the blue current. Okay, so I had this current. I got this resistor right here. So let's go there and let's write I3 as a 0.24 amps, and I can calculate the third thing, right, by multiplying 8 times 0.24, and I have a 1.92. Yep, 1.92 is the voltage that I will read if I put a voltmeter here. 1.92 volts right there. So you see how I'm calculating every possible thing in the circuit. Okay, so now let's keep on following the table. I have almost everything. I just need to conclude everything else. So across R5, can I calculate anything? Well, I had 2.3 here voltage wise. So this current, this circuit doesn't, I don't need this anymore because those clamps are connected here and here. Okay, so if I have a 2.30 volts and I'm losing 1.92 volts now, right? So 2.3 minus 1.92, I have 0.38 volts right here. Okay, so this, if I have a voltmeter there, I will read 0.38 volts. Okay, so this is R5, so where I see V5, I put down 0.38 volts. I got two things. I can calculate the third. So 0.38 divided by 5 will give me a 0.08, which is the orange current. Okay, so 0.08 amps. 0.08 amps. Okay, so now current-wise, I started with 0.24. I'm losing 0.08. So 0.24 minus 0.08, I have a 0.16. Okay, so this pink current is going to be 0.16 amps here and 0.16 amps here. Okay, so this is the current across R6, which is I6. So 0.16 amps will go there. And this is the current across R7, which is 0.16 as well, because this is a series circuit, so no surprises there. I got two things. I can calculate the third one, which is those voltages across R6 and across R7. Okay, so 3 times 0.16 gives us a 0.48 volts, and 2 times 0.16 gives us a 0.32 volts. And basically with this we are done. But please make sure that you have the whole shrinkage of circuits first. Once you have your equivalent resistance, then by all means go back and fill in the table. And I'll see you tomorrow. Bye.